Hello students, in today's video I will be discussing about salt analysis. Now since your practicals are coming, you should be well prepared with 3 sets of the experiments, that is salt analysis, volumetric and content based. Volumetric experiment, how to perform that, I've already posted the video, please watch that. And in today's video I will be completely explaining salt analysis. Means if some unknown salt is given, how do you identify the anion and cation present in the salt? Okay, so this will be very helpful to you to answer Viva questions also. And you will be able to analyze what is the anion cation and will be able to also write the complete procedure without any issue. Okay, so every salt we know consists of one anion and cation. It is having anion and cation. So anion is also called as acidic radical. Acid radical or acidic radical. Right. So first, whenever a salt is given, you always begin with anion testing. You will always start with anions. Right. So when you start with anions, you have to see that the salt analysis, the testing of anion is divided into 3 categories. That means dilute sulfuric acid group, concentrated sulfuric acid group and independent radicals. Right. So dilute sulfuric acid. There are 4 ions present. One is carbonate ion, sulfide ITE, sulfide, nitrite ITE. With concentrated sulfuric acid, there are 3 ions again, chloride, acetate, nitrate. Apart from that, you have also bromide and iodide. Yes, so bromide iodide also will give a positive test with concentrated sulfuric acid. And if this is not there, then you have the independent radical, that is sulfate. In the independent radical, you have phosphate also. These 2 ions, they do not give any test with the dilute and concentrated sulfuric acid. Right. So this is the grouping of the anions. Now how actually you begin with? Suppose you take a salt in the test tube. To that you will add dilute sulfuric acid. So this is dilute sulfuric acid. What all tests are there? That means you will take salt. To the salt you will add dilute sulfuric acid. And you may get any one of the possible observation. Like for example, if you take salt and you have added dilute sulfuric acid, you get brisk effervescence, fast bubbling of a gas is seen. The gas which is evolved is carbon dioxide. And how do you check the gas is carbon dioxide? You pass the gas through lime water. That means you pass the carbon dioxide gas into the another test tube which is containing lime water. It will turn milky. It indicates the presence of carbonate ion. These are preliminary tests. For the ions. Right. So with brisk effervescence, if you are getting carbon dioxide is the gas, how do you check the gas is CO2? By passing the gas through lime water. It means it is carbonate. If suppose you may not get this, you may also get pungent burning sulfur like smell. As if sulfur is burning, like that smell if you get. The gas which is evolved is SO2. And how do you check the gas is SO2? On the mouth of the test tube only, you just keep a filter paper which is dipped in acidified potassium dichromate. Filter paper immersed in potassium dichromate acidified, just keep it on the mouth of the test tube. Like this is the test tube, bring it on the mouth of the test tube. You will get that this paper will turn green. If it turns green in color, it is sulfite ion. Okay. And suppose you do not get this. You do not get this also. Maybe you get rotten eggs like smell. Colorless gas with rotten eggs like smell. Rotten eggs like smell is of H2S gas. And the gas is tested by passing, this particular gas through this lead acetate. Or you can say, you can just dip a paper dipped in lead acetate, place it on the mouth of the test tube, dip a filter paper in lead acetate, place it on the mouth of the test tube, it will turn black in color. it means it is sulfide ion. You will not get all the tests. When you are taking salt with dilute sulfuric acid, either if it is carbonate, you will get this test. If it is sulfite, you will get this test. If it is sulfide, you will get this test. If not sulfide, you may get reddish brown gas. The gases of NO2, which will turn the ferrous sulfate solution black. Then it is nitrite. Okay, but if you do not get any reaction with dilute sulfuric acid, if you add sulfuric acid, dilute, if you do not get any reaction, it indicates the absence of all these ions. You have to write down like this. Indicates absence of carbonate, sulfite, sulfide, nitrite ions are absent. Right? Indicates absence of these ions. You will write down like this. Is this point clear? One thing very important, to the salt, you will add dilute sulfuric acid, not to the salt solution. Always avoid adding water to sulfuric acid because the reaction is very exothermic. Right? So suppose you do not get any reaction with dilute sulfuric acid. What will you write? Salt, dilute sulfuric acid is added. No characteristic reaction is observed. No characteristic gas is evolved. Indicates the absence of this. That means this will be in the experimental column. This will be in the observation column. This will be in the inference column. Right. So this was the complete set of dilute sulfuric acid. Now, if it is not these 4 ions, then it can be some other ion. So how to go about that? Let us see. Now, suppose you take with concentrated sulfuric acid. Again, to salt you will add concentrated sulfuric acid. And moreover, you are using sulfuric acid, so you will not hold the test tube with hand. You will have to use a holder, test tube holder. You will add sulfuric acid. If it is chloride, then it will give colorless gas with the pungent smell. The gas which is coming out is HCl. And how do you check the gas is HCl? Bring a rod dipped in ammonia solution near the mouth of the test tube. Okay, that means this is the test tube. You have added sulfuric acid. Before itself, in the other hand, the rod dipped in ammonia solution should be ready. Keep it on the mouth of the test tube like this. Don't insert it inside. Just keep it on the mouth of the test tube. You will get dense white fumes of NH4Cl. So that means this is a pre-test, preliminary test for chloride ion. Right? So you are getting HCl gas with this. Suppose to the same test tube which is having salt and sulfuric acid, you add MnO2. MnO2 is a good oxidizing agent. It can oxidize that HCl to chlorine, which is greenish yellow. Then in that case you will get greenish yellow gas of chlorine. This is not to be done in a separate test tube. In the same test tube, when you added this, HCl you have tested by ammonia, and to the same test tube now you add MnO2. Don't take more time in adding MnO2. This should be ready before itself, because the gas will not wait for you to bring the MnO2 powder. Okay, this is oxidizing agent. So what is this doing basically? It is oxidizing that HCl gas which was released here to chlorine. So you get chlorine gas, greenish yellow chlorine gas is obtained. So this will be in your experiment column, this will be your observation, and this is your inference. Maybe it is chloride ion. Maybe it is chloride ion. Then we'll have to confirm whether it is chloride or not. How can we confirm it is chloride? We will have to perform the confirmatory test. Confirmatory test. We'll have to perform confirmatory test. There are 2 confirmatory tests for it. One silver nitrate test. Another one is chromyl chloride test. The lower one is chromyl chloride test. This one is silver nitrate. So what is silver nitrate test? Salt solution. Add silver nitrate solution. You will get white PPT. White PPT which is soluble in NH4OH. That PPT should be soluble in NH4OH. Whenever you are checking the solubilities of the PPT, take very little quantity of the PPT to check the solubility. Okay, the PPT will be of this chloride from there and Ag from here. That means the white PPT composition will be AgCl. AgCl is white PPT you are getting. That PPT should be soluble in NH4OH. It confirms the presence of chloride ion. This is confirmatory test. There is one more confirmatory test, that is chromyl chloride test. In this, salt, potassium dichromate, you add concentrated sulfuric acid, you will get reddish brown vapors. Reddish brown vapors of chromyl chloride are obtained, which you collect in the empty test tube. How? You are taking, say, salt, this and sulfuric acid, the empty test tube, you will invert it over it. Collect the vapors in the empty test tube. Cover this with the thumb. In this empty test tube, now you add three things. Which three things? You can remember like that. BAS you're adding. B base, NaOH, A say acid, acetic acid, S is salt, lead acetate you're adding. You will get yellow PPT. Even this is confirming the presence of chloride ion. So if it is chloride, you will be writing these three. These four. First two pre-test, then these two confirmatory. There are two pre-test and two confirmatory. Suppose it is not chloride, then you will write down salt plus concentrated sulfuric acid is added. That case you will write no characteristic reaction is observed, indicates absence of chloride ion. If it is chloride only, you are writing all this. If it is not chloride, then you will write this no characteristic reaction is observed, indicates the absence of chloride ion. Then you will say that chloride is absent. You have to search for another ion which can be present. What can be the other ion? The other ion can be acetate. So you will write with salt and concentrated sulfuric acid, no reaction observed, absence of chloride. To the same test tube, salt and sulfuric acid was already added. Since no reaction was there, you did not perform chromyl chloride test, silver nitrate test, that you did not perform. Now the same test tube you will be heating it. That means salt plus concentrated sulfuric acid is there, H2SO4 is there. You did not get anything from chloride, you heat the test tube. When you heat it, you will get vinegar like smell. If you get vinegar like smell, that means probably it is acetate ion. But we cannot rely on the smell. We have to perform confirmatory test. To perform the confirmatory test, you will have to do ferric chloride test. This is FeCl3 test. So salt solution, add neutral ferric chloride solution. You will get red color filtrate. To that you will add tap water. Here you add tap water and you have to heat it. On heating this red filtrate with tap water, you will get reddish brown precipitate. It confirms the presence of acetate ion. So if it is acetate ion, you will write down no characteristic reaction for chloride. Then the same test tube you will heat, vinegar like smell will be there, you will say acetate is present. Then you have to perform this test, confirm it. If suppose you do not get this also, you will write salt plus sulfuric acid, no reaction observed, absence of chloride. You have to heat the test tube, no vinegar like smell, absence of acetate. That means if it is not chloride and not acetate, you have to write down the absence test also. Okay, so if it is acetate also absent, then what is the probable other ion present? It can be nitrate. So that means salt, sulfuric acid, you have already heated it. To the same you add copper turnings. Now already it is hot test tube. You can add copper turnings to the same. You will get reddish brown vapors of NO2. So might be nitrate ion present. This indicates maybe nitrate ion. So nitrate ion has to be confirmed. But now this is a hot test tube. So what you have to do is you have to cool the outer walls of the test tube under tap water and throw this content in the sink. Take your hand inside the sink, throw the contents and then you add water to it. Never add water to the hot test tube. You have to cool it from outside. Outer walls have to be cooled under tap water, then you throw it in the sink. Now you have to perform this test, confirmatory test. This was the pre-test. This is the confirmatory test. Confirmatory test for nitrate is brown ring test. This is brown ring test. Salt solution, ferrous sulfate solution, sulfuric acid along the walls of the test tube. You tilt this test tube on the left side, left hand side, and add sulfuric acid along the walls of the test tube. And at the junction of the aqueous and acid, you will get brown ring. It indicates nitrate ion is present. This is confirmatory test for nitrate ion. If suppose with copper chips also it is not giving any reddish brown gas. You will write no characteristic reaction observed, absence of nitrate. That means if nitrate is also not there, you will write absence test for chloride, absence reaction for acetate, and absence of nitrate. Then you will go ahead with the independent radical. Okay. Now this is the independent ion, sulfate ion. So it doesn't have any dry test. There is only one wet test for it. You will prepare salt solution, divide into two parts. To one part you add barium chloride, to the second part you add lead acetate. Both the cases you will get white PPT. So white PPT confirms the presence of sulfate ion. Okay. Now after you search for what is the anion, you have to go ahead with the cations present in it. Okay, so first thing is the cations are divided into 6 groups. They are divided into 6 groups. So I've just made a tabular column to explain. This is also called as a basic radical. Cations are also termed as the basic radicals. These are the groups. 0 to 6 group. Total 7 groups are there. These are the group reagents for each group. The PPT or the gas, what is evolved? This is a gas. And confirmatory test and what are the ions. Okay. So what you do in this is, after you have tested the anions, you have to check for what is a cation present. And the cations are placed in 7 groups. 0 and then 1 to 6. On the basis of the solubility product values, KSP values of their precipitates. They are classified. The ions which are lying in one particular group have the KSP values in one particular range. It is on the basis of the KSP values they are arranged in various groups. Right? So the first is 0 group. 0 group. 0 group you have ammonium ion. And what is a group reagent for 0 group? Salt. It is not salt solution, salt. NaOH you add and you have to heat it. When you heat, you get ammonia gas. This is ammonia gas evolved. How do you check the gas is ammonia? Bring a rod dipped in HCl. This is a HCl rod which is dipped. Bring it onto the mouth of the test tube. You will get dense white fumes. Dense white fumes are obtained of ammonium chloride, which indicates it is ammonia. Ammonium ion present. Salt, NaOH, heat, ammonia smell. Check whether it is ammonia by a rod dipped in HCl and confirm it whether it is ammonium. So for confirmatory test you have OS. OS means original solution. Salt solution you will prepare. You will add Nessler's reagent to it. You will get brown PPT, indicates ammonium ion. If it is not there, you will write salt, NaOH on heating, no characteristic reaction, 0 group absent. You will write like this, 0 group is absent. So you have to go in the same order, you cannot change the order. Suppose it is not ammonium, you have to write down its absence. Then you will proceed to group 1, which is having group reagent, OS, original solution, plus dilute HCl. If it is there, you will get white PPT. White PPT is of PbCl2. That PPT is to be dissolved in water. Always whatever PPTs you get, you have to dissolve in suitable solvent so that you get a solution, and with that you have to perform the confirmatory test. So PPT here is dissolved in water. You are getting PPT with HCl, so you will not dissolve PPT in HCl. And then that dissolved thing you will divide into 2. One part add potassium iodide, second part potassium chromate. In both the cases you get yellow PPT, it is indicating lead. Suppose with salt NaOH, no reaction, group 0 absent. OS and dilute HCl, no reaction, first group absent. Might be second group. Second we don't give normally because it is colored iron, blue color. So that we don't give. So you can write down that OS dilute HCl. This is the reagent already there in it. Extra what you are adding is H2S. So what is the group reagent for group 2? You will say OS dilute HCl and H2S. If it is copper, it should be giving black PPT, and the black PPT should be of CuS. So you will write down, if it is no ion present till here, this plus this, no reaction, 0 group absent. OS plus HCl, no reaction, first group absent. OS, HCl and H2S, no reaction. Group 2 also absent. Go ahead with group 3 then. Okay, now you just observe. In group 3, 4, 5, 6, there is something common. So this I am just showing together in one frame. OS, that is original solution, ammonium chloride and ammonium hydroxide you have added. If you get white gelatinous precipitate, shake the PPT and see. If the PPT dissolves, it was not aluminium. If it is retained, it is aluminium. You will get white PPT and the PPT is of aluminium hydroxide. So how do you check? Blue lake test you have to perform. This blue lake test. The PPT is first to be dissolved in dilute HCl. And after you dissolve in dilute HCl, you have to add blue litmus solution and NH4OH. You will get blue lake formed. Blue lake will be formed floating on the top of the PPT. This indicates aluminium ion. Okay. If suppose you do not get white gelatinous, you will write down this added, no characteristic PPT, third group absent. Then that solution you will divide into 3 parts. This is first part, this is second part, this is third part. With OS, ammonium chloride, ammonium hydroxide, you will divide into 3 parts. In the first part, you will test for group 4. In second part, you will test for group 5. Third part, you will test for group 6. Okay, so this part was common. So this to the first part, if you add H2S and you get dirty white PPT, it is fourth group present. That PPT is of ZNS because the zinc is the ion. So PPT again to be dissolved in HCl, dilute HCl, and you will divide into 2 parts. That is NaOH, one part, you will get white PPT. Potassium ferrocyanide, second part, you will get bluish white PPT. So if it is this first part with H2S, it is giving some positive test. Go this way. Forget about the second and third part then, because you already got one ion. If you do not get dirty white PPT, you will write down this whatever was there. H2S is added, no reaction, group 4 absence you will write down. Then to the second part you will add ammonium carbonate. So when you are adding ammonium carbonate, you will get white PPT. For both barium and strontium, there are 2 ions present in it. So both PPTs are of carbonates because you have added carbonate, ammonium carbonate. The PPT is to be dissolved in acetic acid. Once you dissolve the PPT in acetic acid, you have to divide it into 2 parts. You will test for barium first. Always you have to test them in the same order. First barium, then strontium, and if calcium also lies in the 5th group, this order. Why? Because barium is very reactive. It will give the test for the lower ones also. Strontium will, like barium will give the test for both. Strontium will give the test for calcium. Calcium will not be giving any test. Okay, so you will test for this. Suppose you did this ammonium sulfate test. You will get a white PPT. You will feel it is strontium, but it was actually barium. So you go in this order. Okay, so you will test for barium, potassium chromate, you will get a yellow PPT. If it is yellow PPT with it, it is barium. If not, to the second part you add ammonium sulfate. So that means once you have dissolved the PPT in acetic acid, only you divide into 2 parts. In first part you test for barium, second part you test for strontium. Both will not be present. Either you get a yellow PPT. If you get yellow PPT, you will not perform this. If you do not get yellow PPT, then the second part is to be used. Otherwise, you have, one confirmatory test for barium strontium also, flame test. Barium imparts apple green color to the flame. Apple green color to the flame. And strontium imparts crimson red color. It imparts crimson red color to the flame. Okay. Now, if suppose with ammonium carbonate to the second part also there was nothing obtained, then the last part, that is this was there, and the third part you will add ammonium phosphate. If you get white PPT, the white PPT indicates the presence of 6th group, and the PPT is of magnesium phosphate and the ion is magnesium. That's all. This is the only confirmatory test for magnesium. Okay, is this point clear? Right, so with this the complete salt analysis is over. So finally you will be writing at the end the report, or you can say the result. You will write down the result. This also carries marks. You will write down the given inorganic salt, contains anion so and so. You write down the formula. Cation, write down the formula, and therefore the salt is. Write the formula of the salt also. Okay, yeah, one more thing I wanted to tell you here. There are at times, Viva questions also asked based upon why is HCl added before adding H2S. What if you do not add? See, HCl and H2S both have a common ion. So wherever a common ion is there, we say the KSP value of this particular precipitate is low. So we provide common ion such that ionization of the weaker electrolyte is suppressed. Ionization of this should be suppressed so that extra ions should not come. Okay, ionization is suppressed so that this why it is suppressed? Because this should not be giving extra sulfide ions. If you do not add, its ionization will not be suppressed. It will give more of sulfide ions, which will give you a PPT even if second group is absent. Same way here, we have added this first. You cannot change the order. You have to always add ammonium chloride and then ammonium hydroxide, because again we need common ion for aluminium hydroxide. The KSP value is low for aluminium hydroxide. So we want limited concentration of hydroxide ion. So this common ion will not allow ammonium hydroxide to ionize to the greater extent. Whereas for group 4, the KSP value is high, because just before adding H2S, between H2S and NH4OH, there is no common ion. We want more ionization of H2S so as to get more sulfide ion concentration, because it should be exceeding this KSP value so as to give the PPT. Because what is the criteria for getting a PPT? The ionic product should exceed the KSP value. Only then you will get the precipitate. Is this point clear? I hope the salt analysis is clear now. Please practice well, and for Viva also you should be thoroughly prepared. Only then you will be able to score well. Okay, the confidence is very, very important. Thank you and all the best for your board exams.